Lesson 8-4 equations as function, and in this lesson you learn to determine whether an equation represents a function and to find functional values for a given function. Okay, let's take a look at this activity: working with a partner or with yourself or with your mom and dad or whoever. Make a function machine using two blank 3 by 5-inch cards. Near the middle of the card, draw these three boxes. Cut out the squares on the left and right. Label the left window input and label the right window output. Okay, write a function rule such as times 2 minus 3 in the center box. So there should be a hole here, there should be a hole there. On the other card, list the integers -5 to -4 in a column about 1/2 inch from the left edge. Tape this card to the piece of cardboard. Okay, and then place a function machine over the number column so that -4 is in the left window. Okay, and then -5 is in the left window. Write the output in the right window. Okay, slide the function machine down so that the input is -4. Write the output in the right window. Continue this process for all 10 inputs. So basically what it's saying is this: you have a hole there, you have the hole there, and you have a piece of cardboard. Okay, and the piece of cardboard should contain, okay, and this will be at the back of the card, should contain -5, okay, -4, -3, -2, -1, 0, 1, 2, 3, and 4. And you slide it in this input, and as you slide -5 behind this cardboard, okay, and you need to write down the output. So -5 times 2 is -10, minus 3 would be -13. So you need to write down -13. So if you write down -4 times 2 is -8, minus 3 would be -11. So this becomes -11, and so on and so forth. Okay, so as you do this, okay, if the input, okay, is represented by x, okay, and this is the whole lesson right here. If the input is represented by x and the output is represented by y, write an algebraic equation that summarizes what the function machine does. So if you notice, if the input is x and the output is y, an equation can be, okay, y equals 2x minus 3, because you're multiplying 2 times x minus 3. Okay, and suppose you were given the output and had to determine the input, how would you go about finding the input? Obviously by working backward. So if you work backwards and you're given the output, let's say you're given the output -11, okay, and then you don't know what the input is, okay, and we know for a fact that our equation is y equals 2x minus 3, okay, and the output is -11, so this is -11. We want to find the value of x. We simply work backward. And how do we work backward? By solving this equation by adding 3, okay, and you end up with, okay, -8 equals 2x, and you simply divide both sides by 2, again working backward, okay, end up with x equals -4. See, and that's how you work backward if you're given the output, okay, and you want to find the input. Okay, so let's go to our lesson proper. The equation in the function machine involved using two variables. Since the solutions of an equation in two variables are ordered pairs, such an equation describes a relation. The set of values of x is a domain of the relation. The set of corresponding values of y is the range of our relation. We learned that earlier in the previous lessons. So in example number 1, we're asked to solve y equals 3x plus 4 if the domain is -2, -1, 0, and 1. And letter B, we're asked to graph the equation. And letter C, it's just asking if it's a function or not. Okay, so letter A, let's solve this. Make a table of domain and corresponding range values. We put -2, -1, 0, and 1 as our x. Okay, and when we do that, when -2 is equated to x, the corresponding value would be -2. Again, if you forgot, this is how we got -2. So if x is -2 and our equation is y equals 3x plus 4, and if we let x be equal to -2, this becomes y equals 3 times -2 plus 4, or y equals -6 plus 4, or y equals -2, and that's the value -2. And we do this for -1, 0, and 1, and the corresponding values for y would be 1, 4, and 7. So after we have created our table, letter B, it's asking for us to graph the equation. So we'll simply graph all the ordered pairs. Okay, and this is how you graph all the ordered pairs. -2, 2, -2, 2 right here, -1, 1, 0 and 4 would be right there, and 1 and 7 would be up there, and simply connect all those points with a straight line. And letter C, use the vertical line test to determine if the equation is a function or not. So we get our ruler again, which creates our vertical line, and this is our graph from letter B, and we simply move that vertical line over to see if it intersects that line at exactly 1 point, and yes, it does. So this is considered to be a function. See, the vertical line passes through no more than 1 point on the graph. For each value of x, the equation is considered to be a function. Okay, let's take a look at another component of this lesson. Equations that represent functions can be written in functional notation. So f parentheses x. Okay, so the symbol f parentheses x is read as f of x and represents the value in the range that corresponds to the value x in the domain. Okay, what does it all mean? For example, f of 8 is the element in the range that corresponds to the element 8 in the domain. Okay, so you can determine a functional value by substituting the given value for x into the equation. So f of x equals 7x minus 5 and x equals 2. Then f of 2 equals 7 times 2 minus 5. So what did we do? We simply got 2 and substituted to x. That's all there is to it. Okay, so this is actually a part of, okay, a part of your domain, which you are substituting to x. Okay, so let's take a look at this example, or before we do that, let's take a look at this one. Letters other than f are also used for names for functions. Okay, and example 2 is a good example of that. If g of x equals 3x plus 4, find each of the following. So that means g of 3, we simply substitute 3 to x. Okay, so g of 3 would be 3 times 3 plus 4. We simply substitute again 3 to x. So g of 3 would be equal to 9 plus 4, or simply 13. Okay, so g of 3 is 13. G of -5 is simply substitute -5, okay, to x, and simplify it. End up with g of -5 is -11. Okay, and let's look at letter C. A little bit, one more step here. Okay, we want to multiply 2 times g of 0. Okay, that means we need to multiply the whole function by 0 after substituting the value of x to 0. Okay, so I'm sorry, let me restate that because I think I said it wrong. Okay, we are basically multiplying the whole function by 2 after substituting the value of x to 0. Okay, so in this case, we have 2 times g of 0 is equal to 3 times 0, right here, plus 4, and multiply the whole function by 2, okay, which ends up with 0 plus 2 times 0 plus 4, or simply 8. Okay, so 2 times g of 0 is 8. Okay, rewind that if you did not fully understand letter C. Okay, and let's take a look at the last example. We can use the real world situations in an equation and represent it as an equation. Oceanographers use sonar to locate fish and other objects beneath the surface of the water. Sonar units emit a pulse of sound and calculate the distance to the object by using the time it takes for the pulse to reflect back. So you can use the function v t equals d, where v is the velocity, t is the time, and d is the distance. Okay, so the speed or velocity of the sound in water is 1,454 meters per second. How far below the surface is a school of fish if it takes 0.022 seconds for the sound to return to the sonar? So the sonar simply works something like this. Okay, a little bit of a FYI. Okay, so this is your boat. Okay, very nice boat. This is your ocean right there. And you have a sonar device, just usually underneath a boat there, and emits a sound. Okay, and then it spots a fish. After it spots a fish, the sonar goes back to the machine. The sound waves travel back to the sonar or to the machine. And the number of seconds for that sound to travel back to the machine will determine the depth of that particular fish. Okay? So let's take a look at this example. Last example is in this lesson. The sound must go to the fish and return, so the time to the fish is 0.022 divided by 2, or 0.011 seconds, because the sonar travels to the fish and back to the fish, and that's the reason why we divide it by 2. So we use the formula Vt equals this d, and substitute the values for velocity and time. Okay, and we end up with the distance is 15.994. You would use the calculator. That means that the fish are about 16 meters from the sonar. And now you can sit there, throw your line out, okay, and estimate the line to be around 16 meters, and hopefully you get to catch the fish. Okay, and the secret word for this lesson would be football. Thank you for watching.